In this video we're going to look at enlargement. So the first example we're going to look at is enlarging by a scale of 3. So we're looking to make this shape, okay, so this square 3 times bigger than it is already. So we can see at the moment it is a 2 by 2 square, and if it's going to be 3 times bigger, we're going to be saying that's going to be times by 3. That's going to be times by 3, which means we are looking to create a 6 by 6 square instead. Now, because we haven't got any measurements on here, it doesn't tell us where the enlargement needs to take place. This can happen absolutely anywhere on the page whatsoever, providing it's within the squares on an exam question. So if I go here, I'm going to say, right, I'm going to go 2, 4, 6, and same across the bottom. I'm going to go across 2, 4, 6, complete my square, which means I have then enlarged my original shape by a scale factor of 3, and that's finished. So we've got 2 originally and a 6 and a 6 now. Now the difference between this question and this question is this actually tells you where the enlargement needs to take place. So as well as the fact that we're going to be considering that this triangle is going to be twice as big, okay, so the scale factor of 2, we also need to consider the fact that the distance from the location 4, 3, so across to 4, up to 3, is also going to be twice as big. So to start off with, we need to work out where our starting point is on our graph. So we can see here, if we pick this corner in the centre, we at the moment need to go down 2 and across 1 to get to that position there. So we go down 2 across 1. Now, similarly to this question over here, each of these steps needs to be now twice as big. So this needs to be times by 2, this needs to be times by 2. So the starting position of this corner here is now going to be 4 down, so 1, 2, 3, 4, and now 1 times 2 is 2, so 2 across. So that corner is now there. Now from that point, we can now just make the shape twice as big. So instead of it being 2 across the bottom, we've got 2 times 2, so we're going to have 4 across the bottom on this shape here, making sure that this corner is where we're starting from. So we've got 2, 4. We can then look at the height of our triangle. So in the original shape it is 2, so in our new shape it's also going to be 4. So that's going to be 1, 2, 3, 4 for the top corner, and from there you simply just join up the corners to make your triangle. Now it doesn't matter if they overlap or touch at all, it's still absolutely fine. Next one, we've got another square on our graph here, and this time we are going to be enlarging this shape by a scale factor of 1/3, about the point -1, -2. Now, contrary to what people think of the word enlargement, in this type of question, enlargement by a scale factor of 1/3, so a fraction, the shape's actually going to get smaller instead of bigger. So when you enlarge by a fraction, the shape gets smaller. A little confusing, I do know. They like to use this in exams because they know it does add a little bit of confusion in. So if we start off by looking at the point -1, -2, so -1, -2, we are looking to see, first of all, as we did in the previous question, how much is the distance between our starting point and one of our corners. I'm going to pick that one this time. So we go across 3 and up 3 for our original shape, which means if it is 1/3 of the size, so 1/3 of 3 is going to be 1 square. Across, and 1/3 of going up is going to be 1 square up. So we can see our new starting position is going to be there. Now remember, once we get our starting position, it's nice and easy to do the rest of the sides because we're going to make it 1/3 of the size again. So we've got a 3 there and a 3 there. When we times this by 1/3 and times that by 1/3, we get a 1 by 1 square at the bottom down here. So enlarging by your scale factor, that is a fraction, the shape is getting smaller. You haven't done it wrong, it is exactly as it should be. I hope this helps with your homework. Good luck, thank you for watching.